I have to say, I really did forget how much of a nightmare this leaving cert was. God almighty. Okay. This one was a really strange question as well. The second part of it's calculus, so once I get past the first part, I'll be okay, but the first part is just strange. So 2 to the 4 is the same as 16. So what are the factors of 16? That's what we're asked to write the factors of 16. So 1 is a factor, 2 is a factor, 4 is a factor, 8 is a factor, and 16 is a factor. So that's the 3 factors. Then it says we can write each one as a power of 2. So I'm just going to do 2 to the 0, 2 to the 1, 2 squared, 2 cubed, and 2 to the 4. So 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8, and 2 to the 4 is 16. So that's kind of interesting, I suppose. And that's the only factors. And then we're asked to work out how many different factors 3 to the 7 has. So I don't have my calculator on me, but I just want to figure out what number 3 to the 7 is. So I'm guessing... Okay, so 3 to the 7 is 2,187. I have no idea how many factors that has, but I'm guessing... Oh, yes, okay, perfect. If it's 3 to the 7, we can actually just do the same thing as we did with the last one. 3 to the 0 is going to be a factor. 3 to the 1 is going to be a factor. 3 squared is going to be a factor. So this is decomposing prime numbers, is it? It's not a prime number though, but... Okay, we're writing it as a product of primes. So that means all of these are going to be factors, I guess. Interesting, but anyway. So write it like this, and 8 factors. Okay? Stupid, but that's how you do it. Just, you kind of have to copy the last question. Then we're asked to work out how many different factors 2 by 10 multiplied by 3 to the 12 has. So I'm guessing if you put that into your calculator, this is going to give you a very big number. And you're not going to be able to tell how many factors it has. But first of all, we can say 2 to the 10 has 11 factors, like we've done the last 2 ones, okay? And we can say that 3 to the 12 has 13 factors. Okay? And then basically we have each one of those powers of 2, like 2 to the 1, 2 to the 1, all of these is a factor. And same with all of these. Jeez, this is ridiculous. So basically the way you get them, the total number of factors is going to be 11 times 13. That's going to be because of the fundamental principle of counting. So technically this is actually on the Leaving Cert. It's in a chapter called Real Numbers, and teachers don't really do it, but it is technically on the Leaving Cert, and this is just a kind of a strange question. But basically when you decompose these, the idea is you can write every number as a product of prime numbers, which is what we do here. And then if you think about it, like 2 to the 1 times 3 to the 1 is going to be a factor. So for every single 2 to the 1, we have 13 numbers, okay? Because we have 3 to the 0, 3 to the 1, 3 squared, 3 cubed, all the way up until 3 to the 12. Then the same thing for 2 to the 2, and so on for every single number. So to get the total number, you do 11 times 13. If that doesn't make sense, don't worry about it. Stupid question. Now the next one's a bit nicer. She looks at the relationship between pairs of factors. She makes a table. That is, complete the table. Okay, so for x, y equals 12. So if x is 1, y must be 12. If x is 2, y must be 6. If x is 4, this must be 3. If this is 6, this must be 2. And then this must be 12. Now let's just do this. So when x is 1, y is 12. When x is 2, y is 6. Sorry, that's meant to be this number here. Right here. Right, now we have this one here is 6. When we have 4, it's 3. And it's going to go, is it going to keep going down? Sorry. Then when it's 6, it's 2. And then when it's 12, it's 1. So like this. And then we're just told to plot. We're not told to draw the graph. So, okay, never mind. We're told to draw the graph. Then the first part is just plot the points. The next one is draw. So just come along like this, and then we're just going to connect all these points here. Like that. Okay, I don't know why that got thicker there, but anyway. That's what we have to do. And then I guess we could just draw. We just write y there. Okay, so that's how you do that one. Then a tangent to the curve 12 over x. So this is the graph we've just drawn here. Is drawn at some point p 12 over p, where p is a real number and p is positive. Then we're told to show that the equation of this tangent is that thing there. So the way I'm going to do this is the equation of a line is given by this here. And I know what the point is. So this is x1, this is y1. All I have to do is find m. So to find m, I do find the derivative and stick in p. So y is 12 over x. So I'm going to differentiate that. So to differentiate that, it's going to be minus 12 over x squared. If you don't know that, it's going to be 12x to the minus 1. Now differentiate that, bring the power down. Minus 1, 12x. Then take away 1 from the power, minus 1, minus 2. Flip it back upside down, minus 12 over x squared. Okay, that's how you differentiate that. Okay, and that's y prime. And it's at the point P. So this is all happening at the point P. So I have to stick in P. So minus 12 over P squared. So this is M. That's how you find the slope at a point for a curve. Anything about tangent calculus, especially for this one here. Now I'm going to sub into my formula. So y minus y1, what did I say y1 was? 12 over p. Is equal to m minus 12 over p squared by x minus x1, which is p. And I'm told to show it's equal to this thing here. So the way I'm going to do this is... Alright, this is pretty simple, I guess. So let me leave the 12 over p here. Let me multiply out the next one. So minus 12 over p squared times x is minus 12 over p squared x, which is actually what we're trying to do. That's what we have, which is good. Now for the next one, minus by minus is going to give us a plus. So it's going to become plus 12. And since this p is up here, and we have 2 down here, that p is going to cancel with the squared. So we just get left with 12 over p. Now, to move, we move the other 12 over p over. So we get this x plus 12 over p plus 12 over p. So 12 over p plus 12 over p is just 24 over p. So I can get rid of this, and I can just write 24 over p. Okay, and that's what we were asked to show. So we're done. Beautiful. I thought we were okay for a second, but anyway. Then we're told that the area formed by, so this is the tangent that's drawn here anyway, is always k square units. Interesting. So this area is k. What's the area of a triangle? Is half the base times the height. Let's remember that. And this is the base here, and this is the height here. Okay. Okay, so see, for this point here, we can find the height if we let x be 0, and down here we can find the base if we let y be 0. So let's do that. So let's say x is 0. So look up here, let x be 0. That's going to give us y is equal to minus 12 over p squared times x, which is 0, plus 24 over p. So that's just going to give us y is 24 over p. So this point here is going to be at the point 0, 24 over p. Or that just means that the height is equal to 24 over p. Now, the base one is a little bit harder. We have to let y be 0. So for this one here, we do 0 is equal minus 12 over p squared x plus 24 over p. Now we have to solve for x. So to do that, we move this kind of x bit over. So we add it to both sides. Now what we do is we divide, let's multiply across by p squared first of all. So we get 12x is equal to 24p squared over p. This p cancels with the squared, so that's just going to give us 24p. Then we divide by 12, and we get x is equal to 2p. 24 divided by 12 is 2. Okay, so that means this point here, or the base, this means this point here is 2p, 0, or it means the base length is 2p. Now I said earlier, half the base times the height gives the area. We're told the area is equal to k. Okay, now I can sub in what I found for base and height. So for base I got 2p, and for height I got 24 over p. And then that's equal to k. Okay, I am asked to work out the value of k, which is nice. So amazingly enough here, see this 2? This 2 cancels with this. 2 halves is 1. This p cancels with that p, and we just get left with k is equal to 24. So k is 24. Okay, that actually worked out a lot nicer than I realised. I did not expect that to come out that nicely. And yeah, we're spot on. And then I guess as well we will write units squared just to get our full marks. But anyway, nice. That was